this video, we are going to explain about experiment with machine learning algorithms. Introduction. Experiment with machine learning is a comprehensive exploration of classification algorithms and their performance evaluation using sklearn package. It involves two distinct tasks to gain valuable insights into the field of machine learning. In the first task, the project deals with the sentiment prediction from the movie review using movie review dataset. Logistic regression is used and it undergoes parameter tuning through grid search and cross-validation to optimize the predictive capabilities. In the second task, on the big ML telecom churn dataset, multiple classification algorithms including support vector machine, random forest, extreme gradient boosting, and logistic regression are experimented, and also impact of normalization on the model performance and the significance of feature selection techniques such as select k-best and principal component analysis is compared. Objective. The objective of this project is to apply and evaluate the performance of different classification algorithms including logistic regression, random forest, XGBoost, and support vector machine on the two distinct tasks. The first task involves sentiment prediction using movie review dataset employing logistic regression with parameter tuning. The second task revolves around the churn prediction using big ML telecom churn dataset. Additionally, the project aims to investigate the impact of data normalization and feature selection techniques such as select k-best and PCA on overall the predictive performance of the algorithms. By comparing the results, the project seeks to gain insights into the most suitable approaches for the task. Requirements of the project are hardware requirements and the software requirements. In the hardware requirements, operating system of Windows, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above are required. In software requirements, Python IDEL of 3.7 version is required. Methodology. For execution of the project, we have designed few modules. In the first module, we will upload the sentimental movie review dataset. In the second module, which is run experimental setup 4, here in this module, we train the movie review dataset with the logistic regression algorithm. Next, third module is upload big ML churn dataset. Here we will upload the big ML churn dataset. Next, the fourth module, run experimental setup. In this module, we will train the big ML churn dataset with the training of SVM, logistic regression, gradient boosting, and XGBoost algorithms. Last module, which is view table results. In this, we compare the performances of the performed algorithms in run experimental 5 setup 5 module. Execution. For execution of the project, first open the code folder. So this is the code folder of the project, and this is the dataset file which contains the data in it. So on the IMDb dataset, we will do the task 1. On the churn big ML dataset, we will be performing task 2. And this is the main file which contains the Python code in it. And this is the run.bat file. Instead of executing the program in command line interface, we created the Windows batch file for execution of the project. So double click on it for execution. So for uploading the sentiment movie review dataset, click on this button. Select the IMDb dataset. Click on open. Click on run experiment setup 4 for execution of logistic regression algorithm. In background, many things are being performed, so it is taking some time. So this is the ROC AOC curve. On x-axis, false positive rate is represented, and on y-axis, true positive rate is represented. So close this image. Now close this tab for seeing the graphs of the logistic regression algorithm. So this is the confusion matrix. This is the 0 count, and this is the 1, and this is the 1, and here is the 0. This blue color lines are the true positive rates. Close this for seeing the other graph. Here on the x-axis the words are represented, and on the y-axis count of the words are represented. Close this for seeing other word count graphs. This is also a similar graph, and also we will get the other graph, so close this. It is also the same graph which has the words on x-axis and count on y-axis. So close this. Now the task 1 is completed. Now we have to execute the task 2. So again, double click on the run.bad file. So the window opens. Now upload the big ML churn dataset. So click on the button big ML churn dataset. Select the churn big ML data. Click on open. Here the dataset is uploaded. Now we will be clicking on the button run experimental setup 5. Here we will be running all the 4 algorithms by normalization and selecting the feature techniques which are select K-best and the PCA. So click on this button. Here are the model performances. This is for the normalization of SVC, which is support vector machine. This is the K-best, this is the PCA of SVC algorithm. Similarly, these are the logistic algorithm performances, and these 3 are the random forest classifier performances, and these are the XGBoost classifier performances. Now we will be clicking on the view table results to see the results in tabular format. So here this redirects to the web page. On the column, on the rows, it is representing the algorithm names, and on column headers we have the techniques like normalizing the data, select K-best, and the other one is PCA. So close this. Conclusion. Experiment with the machine learning demonstrated the effectiveness of the logistic regression in sentiment prediction from the movie reviews. Additionally, the evaluation of XGBoost and random forest classification algorithm on churn prediction revealed that all achieved notable accuracy scores without feature selection techniques. Noticeably, logistic regression and support vector machine consistently outperformed even after applying select, K-best and principal component analysis. The project highlighted the significance of algorithm selection and showcased the impact of normalization on model performance. These findings provide valuable insights for future classification tasks, emphasizing the importance of fine-tuning approaches for optimal results in machine learning applications.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.